Right, today we're going to talk about mainly order of operations stuff. So click all the Chromebooks all the way close, please. Okay, little review. I mean, what about something like this? Again, we're shaking the rust off from the summer. Let's look at a problem like this guy. We want to talk for a second about how would we subtract fractions like that? What do you do? We need a common denominator, right? Let's get rid of earbuds, please. When we're dealing with adding and subtracting fractions, we've got to get a common denominator. Multiplying fractions, piece of cake. You multiply straight across. Adding and subtracting, a little tougher because I need a common denominator. First question, what is the common denominator? 10. Okay, good. How'd you get that so quick? Okay, so if you had to explain this, say you had to explain that process to a younger student, younger cousin or sibling or something, how could you explain that to them, to know how to do that? You found 10, how? You can talk about it either way, kind of, but what did you do? Just using simple words, you fill in the blanks, you found the smallest number that does what? Okay, the smallest number that each denominator divides into? Isn't that kind of what you did? The smallest number that both 5 and 10 divide into is 10, right? There you go, okay? That's a great way to do it. Raise your hand if that's what you did. I mean, you got the answer, but you didn't think about it in those terms because it's just so quick. You've done it so many times, it's so intuitive for you. But if you had to write a process down, isn't that what you did? I bet it is. Okay, there is an alternative, and that is a great way to do it when it works, when it's simple. It could be more complicated though. What if the denominators were things like, 128 was one denominator and 42 was the other denominator? What's the smallest number that those both divide into? No, that they both divide into. It's going to be an enormous number. Who would know, right? You couldn't really use that strategy anymore, right? So what's another strategy? We'll talk about another one, even a more efficient one later when we review factoring. But for now, let's just look at one that always works. You could always use this if you need to. Finding the least common multiple. The common denominator, the least common denominator is the least common multiple of all the denominators, always. What is that though? First of all, what are multiples? Let's make a couple lists of multiples for these denominators. What are the multiples of 5? Okay, now I'll get you started. The first one is 5. What's the next one? 10. Okay, good. So the multiples are 5, 10, and so on, right? So multiples are what you get when you multiply by 1, 2, 3, 4, etc. Multiply by the numbers in the set of the elements of the set of natural numbers, starting at 1. Okay. Multiples of 10. So on, right? Okay, so the LCD, least common denominator, is equal to the LCM, which is the least common multiple. Think what that means. Let's break that down. We throw these words out in math, but rarely do we ever really think about what they mean. What does least mean in math? Smallest, or lowest or smallest, right? Common in math. Same, right? So what is the smallest, same, or smallest shared multiple in those lists? 10. That's it, right? It's 10. Right there. That's our LCD, 10. That always works, every time. If it's too hard to find it the other way, you can always look for the least common multiple, okay? All right, so now that we know it's 10, what do we have to do to get 10 in both our denominators? Thank you, sir. Yes, okay, good. We need to multiply So we already have 10 in the second denominator. That's taken care of, but the first one we have a 5, so we need to multiply by 2 to get there, right? So do I just multiply only the bottom? What do I do? Top as well. Okay, how come? Say that again. Okay, good. I have to. Why is that? What's a way you could, again, if you had to explain that to somebody at a lower math level than you, why? Yeah, we don't want the original value of the fraction to change. If I turn 3/5 into a decimal on my calculator, aren't I going to get 0.6? Agreed? I can't ever change. It has to always have the same decimal value, the same value. I just want to make it look more convenient for me. I want to rewrite the fraction so the denominator is 10 instead, right? So I need to multiply both the top and the bottom by the same thing to keep that ratio the same value. Think about another way of looking at that. If I multiply both the top and the bottom by 2, I've multiplied the entire fraction by 2 over 2, which is what? What's 2 divided by 2? Ooh, 1 is a good number to multiply by if I don't want to change the value, isn't it? Talk more about that day after tomorrow. That's the identity number for multiplication. 1 is. When I multiply something by 1, it stays the same, right? The only number that would work for that is 1, special number, okay? So then we do that. We multiply straight across in that first fraction. On the top, we're going to get 6. On the bottom, we get 10 minus 9/10. Now that I've got a common denominator, did you guys used to talk about pushing the fraction together with a common denominator? You remember that? Give me thumbs on that. Does that make sense if I say we're going to push the fraction together into one fraction when we get a common denominator? This is my common denominator. Right, here it is. Here, I gotta fix something here. This is driving me nuts. I need more colors. There, much better. Okay, look at this. I've got the same denominator in the bottom. So I could rewrite this as one big fraction with the common denominator 10. Right? What goes in the top? 6 minus 9, right? Everything else, all the other stuff gets compressed into just the single numerator. So all this stuff up here, 6 minus 9, goes in the top. What's all that equal to? Yeah, I'm just going to get on the top, 6 minus 9 is -3. On the bottom, I get 10. There's my answer. Okay? Give me 1 to 5. Is that all making sense? Is that ringing a bell? I know this is just review. Again, we're just shaking off some rust. Okay? Questions? All right. Okay, let's shift gears. Order of operations stuff. So I'm going to skip forward for a second. When I say order of operations, for you guys, that means PEMDAS, right? Okay, what is PEMDAS? What's the P stand for? Parentheses or brackets, anything that's grouping, right? Anything that groups stuff together counts as parentheses, right? So parentheses really means grouping. So things like parentheses, okay, how about this? If we have simplify expressions within grouping symbols starting with the innermost set and working our way out. Fraction bars, always, if I have fraction bars, everything in the numerator, there are implied parentheses, all that stuff is grouped, right? Same thing in the denominator. One other thing here, they put absolute values in the wrong place. Absolute value bars should go up here, shouldn't they? Absolute value bars go under P. Anything that groups goes under P. What's E stand for? Exponents and roots. How about that? Why roots? That seems a little weird. We'll talk about that in a little bit. Roots count as exponents. Okay. Once we skip down from E, we get to M and D. How come the M and the D are on the same line and the M isn't above the D? Okay, because they're on equal footing, right? We're just going to take all multiplication and division in order from left to right, just like we're reading a book. And then finally, last but not least, addition and subtraction. Again, they're on equal footing, so we'll take all instances of addition and subtraction from left to right. Okay, so given that, let's go back and let's look at this first one. What's the answer? 25? Ooh, who said negative 25? How come it's negative? That's right. How come it's negative 25? There's no parentheses. If we follow order of operations, what's the first thing we run into here? Any parentheses? No. What's next? Exponents. What's being squared? The 5, not the negative 5. The 5 is being squared, right? So that's really equal to negative 25. When does the negative get attached? That's multiplication. We're going to multiply that negative 1 times the 25 and get negative 25, right? Okay, compare that to the second problem. What's that one equal to? 25, okay? So this is why do I bring this one up? Because this might be the very most common mistake that people make in math when they're doing computations or calculations. Although people do it in my calculus class all the time. It's the most common mistake. They want to square something that's negative and they punch it in their calculator and they get a negative answer instead of a positive answer. So what's the resolution here? If you're squaring a negative number, what do you always have to do on your calculator? Include parentheses, right? Okay, that's kind of unfortunate because that is a lot of extra buttons to push on your calculator, a lot of opportunities for mistakes. So let's see if we can come up with a good shortcut that avoids that. Anybody else have another option? Anytime I'm squaring a negative number, what could I do to push fewer buttons? What is it? Okay, that's a lot of buttons to push though, right? Let me ask you this. What's always going to happen if I square a negative number? What's the outcome always going to be? If I square a negative number? Positive, isn't it? A negative times a negative is always positive. Okay, so if we know that, if any time I square a negative number, I know I'm getting a positive, what could I do instead? Yeah, just always make it positive. When you're squaring the number, don't even include the negative. If you're squaring it, or for that matter, let's be more general. A negative number to an even power is always to an even power. So if I'm going to take it to the second power or the fourth or the 10th or the 100th, what's the sign going to be? A negative number to an even power. Positive every time, isn't it, right? A negative number to an odd power is going to be negative every time. So you can always, just to make your life easy, you can always just start with what the sign of the answer is going to be and just take the number to the power to get the rest of it, right? So if I want to square negative 47, what would I do on my calculator? 47 squared, because I know the answer is going to be positive, and then I know I'm not going to make that sign mistake. Does that make sense, everybody, what I'm saying there? I think that's a really good idea. You can avoid that mistake if you just remember that rule. Okay, how about something like this bottom one here? I've got a negative number to an odd power, cubed, right? 3 is odd. What's the sign going to be? Negative. So you already know it's going to be negative, right? What could I do to make the rest of it a little bit simpler? If I'm taking a fraction to a power, is there a way I can split that to make it a lot easier? Because if I think of it as a fraction, it's kind of complicated. 1/4 cubed means 1/4 times 1/4 times 1/4. That's a lot of fractions being multiplied. What could I do? There was an idea. Yep. Yeah, you could split it and cube the top and the bottom separately. That's a great idea, right? So I could write this as negative 1 cubed over 4 cubed. Now that's a lot easier. What's 1 cubed? 1. What's 4 cubed? That's a lot easier than 1/4 cubed, isn't it, right? Okay, give me thumbs on that. Does that all make sense too? Is this ringing a bell, these little tricks? Okay. All right, how about moving on down here? These are just some problems that you'll see stuff like this on the assignment. Select the correct choice, and if necessary, fill in the blank. Okay, so first of all, which row is going to be true, A or B? Vote with your fingers. 1 for A, 2 for B. Am I going to get a real number, meaning I'm going to get an answer? Or it's not a real number, so I don't get an answer? It's 1. Yeah, I'm going to get an answer. For sure, I'm going to get an answer. Oops. Okay, now again, what's my trick? What could I do here? The negative is outside of the radical, so it just stays there, right? There you go, beautiful. Split it up so you're square rooting the top and the bottom separately. What's the square root of 25? What's the square root of 144? Done. Look at that. You got it. Okay? How about this one? Vote with your fingers. Row A or row B? Well, I'm seeing lots of different answers. 2 is correct. How come?
Because the negative's inside of it.
Yeah, there's the difference. Okay, now let me hit this one for just a second. Put this in some context for you. This is the issue. The negative is inside. There are only 2 rules to follow when we're dealing with real numbers. One of them we have already talked about last week. One rule for real numbers is I can never divide by what number? 0. Can't divide by 0, right? The other one for real numbers is this. I can't take a square root of what kind of number? Negative, yeah. Or any even root. I can't take a 4th root or a 6th root or an 8th root. I can't take any even root of a negative. For us, really, we're going to focus on square roots mostly, though. Okay, so this one is B. Whoops, gosh. And we're done. It's not a real number, so we can't simplify it. It isn't a number. Okay, make sense? Okay, 2 rules. Remember those 2 rules. Okay, last one. The 4th root of 16. Is that a real number or not? It is. I'm going to get an answer. Okay, we know if I put it in a calculator, it's going to give me an answer. Okay, the problem is, this is kind of a weird one. First of all, how could I even put that into a calculator? Anybody know? Okay, but now the problem here is I'm taking a 4th root. Let me ask you this, okay? The square root of 16 is what? 4. Okay. Because why? Prove it. Okay, because 4 squared is 16. Everybody agree? Okay. Okay. So the 4th root of 16 is going to be some number, because what would I have to do to that number to get 16? I have to take it to what power? The 4th, right? What's the answer? The answer is 2. The answer is 2. You're right. The answer is 2. Okay, and again, I just want to know the answer is 2. Why? Because 2 to the 4th is 16. Everybody see the connection there? Okay. This is the answer because two to the 4th equals 16, right? So can anybody tell me what the 6th root of 64 is? It would have to be whatever number I could take to the 6th power and get 64. It's 2, yeah. It's 2, okay? All right. We'll talk a lot more about these things later. Oh, my trick. How could I do this on a calculator? If I wanted to do the 4th root of 16, if you look at a calculator, there's a square root button and then there's a cube root button, and it's kind of complicated to use the nth root button where you have to change the radical. It's a complicated bunch of buttons to push. It's pretty tough. I mean, you can make it work, but it's almost not worth it. There's a great shortcut. If I want to do the 4th root of 16 on a calculator, This is why roots or radicals count as exponents, because I could write this as 16 to the 1/4 power. How about that? In fact, I can do this for any type of root. Okay, see if you can see the pattern here. The square root of 10, if I want to find that, what's the number that we never write that sits on the radical for a square root? What kind of root is a square root? Second root, yeah. So a square root, there's an invisible 2 that sits there. The square root of 10 is equal to 10 to the 1/2. The cube root of 7 is equal to 7 to the 1/3. The fourth root of 9 is equal to 9 to the 1/4. You guys make a prediction for me. What's the 11th root of 17? 17 to what power? 1/11. Yeah, you get the trick, right? You already know the pattern. If I want to turn a root into an exponent, the exponent is going to have a 1 in the numerator, and the denominator corresponds to the index of the radical, meaning what kind of root is it? What number, what kind of root is it? Okay? That's a lot easier to do. If I want to do a 4th root, that's pretty easy to enter on a calculator. Pretty hard to figure out how to enter a 4th root. Okay? All right. Order of operations stuff. Let's practice this. Okay, so order of operations is important because without a specific order of operations, what 2 answers could we legitimately get from that problem? What's one answer we could get? 100, right? 100 we could get if we divided 20 divided by 2 first and get 10 and then multiply by 10. What's the other thing that if we didn't have an order of operations we could also get? We could get 1. 10 or 2 times 10 is 20. 20 divided by 20 is 1. Well, they both can't be right. We have to have a specific order of operations. So which one do we have to do first? Yeah, we have to go. Those are both on the same row. They're both on the multiplication division row, right? So we're going to have to do the first one we see from left to right. So we do that guy first. Okay, so 20 divided by 2 is 10. 10 times 10 is 100. Boom. Okay, how about this one? What's the first thing we would do here? Good, because we have stuff in the parentheses, right? Make sense? Stuff in the parentheses. So we have to simplify inside the parentheses. And that gives us -3. What's next? Exponent. What is the quantity -3 squared? +9. Okay, good. So we do exponents. Okay, what's next? Multiplication. 2 times 9 is 18. And then finally, add them up. We get 19. Okay? What about... Okay, I'm going to make one up here. What about this guy? What if we did... What do I do first here? What do you think? Okay, yeah, I got to do the stuff inside the square root. So in PEMDAS, technically, what's the first thing I run into? Grouping symbols. Because if I have stuff grouped together inside a function, I have to simplify that first. So the first thing we would do here is P, and that would mean we're going to turn 11 minus 2 into a 9. So technically, that's a P level step. Everybody get that? A grouping level step. That gives us square root of 9 over 6. Now what's next? Okay, exponent, right? A root is like an exponent, so square root of 9 is 3. And then finally, I would just have to simplify that quotient. What is 3/6 would simplify to? 1/2. Good job. Okay, one more. I'm going to make one up here. How about this one? What if we've got what's first? Okay, so the 9 minus 5? How come we do that before we do 4 plus something? Okay, if we have nested grouping symbols inside grouping symbols, we go inside out or outside in? Inside out. We go start at the inside ones and work our way out. So step number 1 would be this stuff, right? So we'd get 4 plus 9 minus 5 is 4 squared. Okay, what's next? Okay, now we're still in the P step. Now we're on the outer grouping symbols. So that would equal 8 squared. And then finally, 64. There you go. Good. Okay, give me thumbs so far. Is this all making sense? Okay. All right. Okay, what in the world do we do if we have something like this where we've got, yikes, we got a bunch of stuff happening in the numerator and a bunch of stuff happening in the denominator. What can we do here to make things simpler? Say it again. Okay, those would be first. Okay, but before we even jump in there, around what? Okay, there are implied parentheses around the numerator and the denominator of all fractions, right? Okay, so then why is it better? How many people in here write their division signs when they write fractions as diagonal slashes? Okay, I'm going to have you stop doing that. And here's why. In the past, maybe that's been okay, but I'm going to tell you why that's going to cause lots of problems for you. What does this mean? Okay, yeah. Did the person that wrote that mean for it to be, was it supposed to be x plus 2/3? Or was it supposed to be x plus 2 divided by 3? You know what I mean? You see the problem there? I mean, technically, if you'd need to put parentheses around this to put it all in the numerator, but you see how complicated that makes things? So what are we, everybody in here, we're going to make a resolution right now. How are we always going to write fractions, do you think? Horizontal division bars with stuff on the top and stuff on the bottom. Well, there you go. Good. Okay, and one nice thing about that then is when we do that, when we want to use order of operations to simplify, we can split off the top from the bottom and work independently on the top and the bottom until we finish the top and finish the bottom, and then the last step would just be to divide. Okay? All right, so on the top, what's our first step? Absolute value. What is the absolute value of negative 2? 2. On the bottom, what's our first step? Square root of 4 is 2. There you go. Okay, so first step is that, right? Next step on the top. Exponent. 2 cubed is what? 8. 2 times 2 is 4 times 2 is 8. Good. On the bottom, only one step left. What is it? Yeah, what is negative 7 minus 2? Negative 9. Bottom is done. One thing left to do on the top. 8 plus 1 is, and then finally, last step. We got the top simplified and the bottom simplified. Now we divide. We simplify the quotient. What's 9 divided by negative 9? Negative 1, and we are done. Okay? All right, so let's do something. Get you out of those desks. Why don't you get up, go to the boards. You can work in groups of 2. You know, if you need to do a group of 3, I think we can do groups of 2. Try that. There's a lot going on there. That's a big one. Yeah. let's touch base on, well, I'm going to let you go back to it. But let's look at this for a second. If we're using order of operations, let's talk through this. There's lots of grouping symbols. On the top, there's a ton going on. I've got brackets. Inside the brackets, I've got parentheses. Inside the parentheses, I've even got stuff grouped. Look at these grouping symbols right here. I've got absolute value bars. Whoops. Right? How do I simplify that? The absolute value of negative 6 plus 2. Okay, good. Now, what a lot of people tried to do here, I think, is they tried to turn the 6 positive before they added it to the 2. But by order of operations, we have to simplify what's inside the absolute value bars first. What's negative 6 plus 2, everybody?
4.
Negative 4, right? So this whole thing is going to become the absolute value of negative 4. What's the absolute value of negative 4? 4. Okay, so all that stuff ultimately becomes a 4. How about this stuff? Let's look over here. Inside, I think this part went better. Inside the square root, 8 plus 1 is?
9.
So the square root of 9 simplifies to?
3.
Okay, now that's looking a ton better. Now look what we get. On the top, inside the brackets, we've got 15 minus. In the parentheses, that just became 4 plus 3. And then everything in the brackets ultimately is being squared, right? Okay, good. On the bottom, what's the first thing I could do? Let's do one step on the bottom while we're at it. Well, how about this 3 cubed? What's that? Yeah, that's 27. Good. 3 times 3 times 3 is 27. So on the bottom, we just get 3 minus 27. Go from there.